welcome once more to tutorial on Best Science Brain YouTube channel. Today we're going to look at another class of hydrocarbons, alkenes or olefins. So if you're not subscribed to the channel, move up now to the channel's name, Best Science Brain. Underneath the channel's name, you have a subscription button. Tap on the button only once and get subscribed to the channel. And if you subscribe to the channel, if you're a subscriber, you'll be seeing our videos from time to time as we release videos in chemistry, general chemistry, organic chemistry, physical chemistry, physics, further mathematics, and practical aspects of sciences. Today, our focus, as I said, is going to be on alkenes. So we'll look at the word alkenes. What are alkenes? We say alkenes are hydrocarbons that contain a double covalent bond between two adjacent carbon atoms. Alkenes are hydrocarbons that contain a double covalent bond between two adjacent carbon atoms and correspond to the general molecular formula of CnH2n with N starting from 2. Unlike the alkenes, alkenes have N starting from 1, alkenes have N starting from 2. And of course, it's good to say that alkenes are unsaturated hydrocarbons. So, alkenes are unsaturated hydrocarbons that contain a double covalent bond between two adjacent carbon atoms and correspond to the general molecular formula of CnH2n with the integer n starting from number 2. So we can represent alkenes structure-wise in this form. So this is the double bond of alkenes, as you can see there. So why do we have a double bond here? We know that carbon is tetravalent. Carbon is surrounded by 4 electrons. And that carbon atom being tetravalent, I have it here. So when carbon, 1 electron bonds with 1 hydrogen atom, this is electron from hydrogen. And that carbon bonds under hydrogen. This one bonds with hydrogen under hydrogen. So we have this. Then hydrogen bond formed. These 2 electrons will come together to form a bond. These 2 again will come together to form a bond out to move up there. So at the end of it, we have this structure. This is a shared pair or bond pair making a bond here. And that shared pair and that bond there, a shared pair of electron giving us a bond, single bond, then bond. Then this shared pair here makes a bond. This other shared pair makes another bond. So that gives us double bond. So as you can see, carbon has satisfied the outer state or in tetravalency. 2 electrons here. A bond is 2 electrons. 2 electrons, 2, 4, 6, and 8. 8 electrons on this carbon. For this other carbon, 2, 4 electrons, 6 electrons, and 8 for this other carbon. While each hydrogen atom satisfies the duplex state, 2 electrons, 2 electrons, 2 electrons, 2 electrons, that duplex state. So we should also know that whenever we have a double bond between 2 carbon atoms, we have to abstract 2 hydrogen atoms. If we have a bond between 2 carbon atoms, we have to remove 2 hydrogen atoms. Like here, the double bond here, 2 hydrogen atoms will be abstracted or removed. And the example is like we have this alkene. Let me say alkene that has 3 carbon atoms. Then there will be an alkene that will be a double bond. somewhere. Either I put it here or I put it there. So to draw the structure, hydrogen should be there, here, and then at these 2 points, no hydrogen will come there because the presence of double bond eliminates 2 hydrogen atoms. Then I'll now bring hydrogen this side, because this place is single bond, it should be saturated. But this place have a double bond, you have to move 2 hydrogen, either down the plane or up the plane. I can as well put 2 hydrogen here, and then remove the 2 on top, you see the same compound. So for alkenes, the double bond is the functional group of alkenes. Double bond remains the functional group of alkenes. So all alkenes must have a double bond between 2 adjacent carbon atoms. So as we said, alkenes are derived from the word olefins. So olefins refers to group of hydrocarbons, organic compound that contain at least a double bond between 2 carbon atoms. At least a double. That olefin can contain more than 1 double bond. So under olefins, we have the monoolefins, that are alkenes. Alkenes are called monoolefins, where because they have only 1 double bond between 2 carbon atoms. They will have the diolefins, that are known as dienes. Example of diene is an alkene that contains 2 double bonds between 2 carbon atoms. This is a diene. For example, the compound called buta-1,3-diene this is a skeleton of buta-1,3-diene. This is a diene or a diolefin, 2 double bonds. Then an olefin that contains 3 double bonds is called a triene. Example, look at this structure which we are trying to get here. So this is a triene, as you can see, triple bond, let number it 1, 2, 3, 4, 5, 6. Triple bond occurring between 1 and 2, 3 and 4, and 5 and 6. So this is a skeleton of hexagon. Or you have hex, that is signifies plural. Like buta, instead of saying boot, there are 2. Plural buta. Then the positions 1, 3. Hexa, 6, so say hex. There are 3 of them, signifying more than 1. Hexa, position number 1, position number 3, position number 5. Triene. Hexa, 1, 3, 5, triene skeleton. So we are not after the diene and triene for now. We're going to meet it in our later or subsequent classes, how to name higher olefins. But our focus today will be on monoolefins, that the alkenes which are introduced as compounds that contain only a double bond between 2 adjacent carbon atoms and have the formula CnH2n with N starting from 2. Okay, now having done that, we'll now move into the nomenclature of alkenes. So the GMF of alkenes, as we already described, of alkenes is CnH2n, where N starts from 2, being unsaturated. For the first member of the alkene family, for the first member, I'll replace N with 2, not 1. While C2H2 times 2, that gives us C2H4. Second member of the alkene family, or the second member, N will be no longer 2, N becomes 3. C3, 2 times 3, that gives us C3H6. For the third member of the alkene family, I'll use N as 4. So C2 times 4 gives us C4H8, and so on. Now, if I want to run through the members without waste of time, I'll take the first member as C2H4. And alkenes make up a homologous series. And as we know in chemistry, in a homologous series, each member differs from the next by 1 carbon and 2 hydrogen. So you continue linking 1 carbon and 2 hydrogen to each member to get the next member. 1 and 2 gives us 3. 2 plus 3 gives us 6. And that's the compound we have there. Then we'll come back again. 1 and 3 gives us 4. It gives us 8. 1 and 4 gives us 5. 2 and 8 gives us 10. 1 plus 5 gives us 6. 6 plus 8 gives us, we keep on adding 1 carbon to each carbon and adding 2 hydrogen to such a hydrogen atom. 1 plus 6 gives us 7. Adding 2 here 14. 1 plus 7 gives us 8. Adding 2 here 16. 1 plus 8 gives us 9. Adding 2 here 18. 1 plus 9 10. 2 plus 18 20. 1 plus 10 11. Then 2 plus 20 22. 1 plus 11 12. 2 plus 22 gives us 24. 1 plus 12 13. That gives us 26. 1 plus this one gives us 14. This gives us 28. 1 plus 40 gives us 15. Gives us 30. 1 plus 15 gives us 16. Adding to 32. 1 plus 16 17. 2 plus 2 gives us 34. 1 plus this gives us 18. 36. 1 plus gives us 19. 38. So C20, H40, C21, H42, C22, H44, and so on. Let me just give a space. C20, H40, C21, H42, adding 1 carbon and 2 hydrogen subsequently, C22, H44, C23, H46. Okay, let's go to the nomenclature, the naming. How do we name alkenes? We name alkenes the same way we name alkane, because alkanes are the principal organic compounds. The first alkane member, if you remember, for our former video, is called methane, that has 1 carbon atom. Second member is called ethane, that has 2 carbon atoms. So, to name alkenes, this is C2, ethane. We go to the alkene. The alkene, the first member has C2, so they're not like methane in alkene. So the second member, the first member of the alkene starts from 2. The name will be derived from ethane. So replace the A and E with E and E. So this one will be called ethene. So ethane, because alkenes will end with E and E. The one will be called propene. Propane, change to propene. The alkane that has 4 is called butane. This one is now called butene. The alkane that has 5 is called pentane. It's called pentene, or like pentagon. This is pentene now. Alkane that has 6 is called hexene. Alkane that has 7 is called heptane. This is called heptene. The alkane that has 8 carbon is called octane. This is called octene. The alkane that has 9 is called nonene. This is called nonene. The alkane that has 10 is called decane. This is called decene. The alkane that has 11 carbon atom is called undecane. This is called undecene. The alkane that has 12 is called dodecane. This is called dodecene. The alkane that has 13 is called tridecane. This is called tridecene. The alkane that has 4 is called tetradecane. This is called tetradecene. The alkane that has 15 is called pentadecane. It's called pentadecene. The alkane that has 16 carbon atoms is called hexadecane. It's called hexadecene alkene. The alkane that has 17 carbon atoms is called heptadecane. It's called heptadecene. The alkane that has 18 carbon atoms is called octadecane. It's called octadecene. The alkane that has 19 carbon is called nonadecane. It's called nonadecene. The alkane that has 20 is called icosane, where it's called icosene. The alkane that has 21 is called N-icosene. This is now called N-icosene. The alkane that has 22 carbon atoms is called docosene. What is now called docosene. Tricosene. The next will be tetracosene, and so on. The molecular formula of alkenes, the molecular structure, otherwise known as structural formula, their condensed formulas, and then their skeletal or line formulas. To solve the first alkene member, is called 18 from the nomenclature 18. So let's draw the structure of 18. There are two carbon atoms. We try to put the two carbon atoms on a straight line. We'll know that alkenes have a double bond between adjacent carbon atoms, and there are only two carbon atoms here. So put the double bond here. And between these two carbon atoms, bear in mind that we should remove or abstract two hydrogen atoms. We'll pull away two hydrogen atoms, either below the plane or above the plane. So if you remove the two here, we'll now fix hydrogen here, here, there, and there. So there is no hydrogen here. Unsaturated. So this is the structural formula of the 18. We'll now go to the condensed formula. The condensed formula, the first carbon is carrying two hydrogen. We'll put them together, CH2. Then at the middle, the double bond. Then this one is having hydrogen again. We'll have CH2 also here. Then going to the skeletal formula, we show the bond between the carbon atom. The bond between the carbon atom is double bond. We just draw the double bond. This is the skeletal formula of 18. The number 2 example, the second member is propene of the family. Then we'll draw the structural formula of propene first. We'll try to put the three carbon atoms on a straight line. After we have done that, since we are dealing with a compound that must contain a double bond, we'll try to put the double bond either here or there. Choose any point of your own convenience. So let me put it here. This place had a double bond. You take away two hydrogen atoms and fill any other vacancy with hydrogen. See the way I did it? So H, hydrogen, H. Remove these two. When you have done that, this propene, if you count the carbon, there are 3 in number. Count the hydrogen, there are 6 in number. So let's go to the condensed formula. The condensed formula. This carbon, the first carbon, is bonded to 2 hydrogen. I have CH2. Double bond is there. Double bond. CH. Take them together. CH3. Put them together. That's the condensed formula. Then going to the skeletal formula of this compound. Or will I draw it? I have this. Let's check whether it is right. 1, 2, 3. There are 3 carbon atoms. 1, 2, 3. Or 1, 2, 3. But there's a double bond. So between carbon number 1 and 2 here, I'll put the double bond there. So this is the skeletal structure of propene. So go to number 3. Number 3 is this. C4H8. This compound is called butene. Okay, let's draw the structure of butene. We have 1, 2. We'll try to put the 4 carbon atoms on a straight line. This is butene. So having done that, we fix a double bond or at our convenience. Let me put it here. Butene. Then this plate double bond is, I have to abstract 2 hydrogen atoms, either below the plane or above the plane. So let me take the below the plane off. Then I have to fix hydrogen on the other vacancy. We have this, and that. Hydrogen, 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 hydrogen. Okay. If you count the carbon, there are 4 in number. Hydrogen, there are 8 in number. Now, the name of this butene, if I want to name this butene, our number from the carbon nearest to the double bond, the functional group. So there are 2 carbon atoms at the extreme, this one and that one. Which of them is nearest to the double bond? It is this one here. So I have to start number from this side, not from the other side. So I have 1, 2, 3, 4. So the name of this compound is but-1-in. How do I get this one? These 2 numbers, I have to choose the smaller one. 1, but-1-in. Otherwise it's called 1-butene. But-1-in or 1-butene. Observe this, the hyphen. So any other name is okay. Then let's go to the condensed formula of but-1-in. So we see the first carbon goes with 2 hydrogen, that becomes CH2. Second carbon goes with 1 hydrogen, that is CH. Third carbon goes with 2 hydrogen, CH2. Fourth one goes with hydrogen, that is CH3. So this is the same thing as this. I forgot to put the double bond. CH2, double bond, okay, CH, then CH2, and then CH3, that's the compound. So let's draw the skeletal formula or line formula. So let me try this. 1, 2, 3. Number 1, number 2, number 3, number 4. Show the position of the carbon atoms. 4 of them. Then we see that the double bond is between carbon number 1 and 2. So between 1 and 2, I put double bond. That one is cancelled but-1-in. So that's the structure. Then let's go back to this butene. You observe that this butene, you can see change the structure somehow. If I try, let me draw another butene skeleton, 4 carbon. Let me shift the double bond to here and see what the name will change. Yes, the name will change. You want a number at the extreme, you check proximity to the double bond. 1, 2, 3. 1, 2, 3. So any end will give you 2, 3, 2, 3. So any end can go. Now I have 1, 2, 3, 4. So this compound would have the name but-2-in, different from but-1-in. So this compound will answer but-2-in or 2-butene. So this, I will have now add the hydrogen atoms. And atoms will come in. This place I have the double bond, I'll subtract 2 hydrogen atoms, maybe below, and then add the ones on top. Then hydrogen atoms will come in. So when you look at this compound, it is still 1, 2, 3, 4, C4, hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, H8. But the position of the double bond here and there are different. The names are different. But they have the same molecular formula, but different molecular structures. These compounds are called isomers. They are called isomers or structural isomers. So let's go to the condensed formula. So condensed formula, here we have CH3. The first carbon has 3 hydrogen. Second carbon, CH, double bond, third carbon, also CH, fourth carbon, CH3. You see, look at the 2. You count the carbon 1, 2, 3, 4. 1, 2, 3, 4. But look at the structure, they are different from each other. So they are isomers. Now let's go to the skeletal formula. We have 1, 2, 3. That is number 1 carbon position number 2 of carbon, position number 3 carbon, position number 4 carbon. Then, where the double bond? Double bond lies between carbon number 2 and 3. Number 2 and 3. You now put your double bond here. So you see that the 2 skeletal formulas are different from each other. So you see the way to draw the skeletal formula of Alkenes and then get their draw them perfectly and get their structures. So perhaps we may look at one more example. We may look at the fourth member called pentene. So for pentene, number 4, pentene is C5H10, pentene. So let us try to get the molecular structures that are possible from this. This is 5. 1, 2, 3, 4, 5. Then double bond must appear somewhere. I can decide to put it here. Then I fill up the vacancy or the vacant spaces with hydrogen, but making sure that I remove 2 from the double bond position. So you have this hydrogen, 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 hydrogen. If you can't it, you're going to get C5 and H10. If I want to name this compound, to name it, I'll start from the position. There are 2 extremes here, this position, this position. To start numbering, I'll number from the end that is closest to the functional group. The functional group of Alkenes is the double bond. So I have to start, this end gives me number 1. Why this end give me 1, 2, 3, 4. So this is closer. 1 and then 2, 3, 4, 5. This is called pent 1E or 1-pentene. Meaning the hyphen comes before and after the number. No spacing. Then let's see whether we can shift the double bond again and get a different structure. When you have this 1, 2, 3, 4, 5, double bond can come here at number 2 position. So now I have 1, fill the hydrogen atoms. Okay, a very simple thing to do. To name the compound, this is 1, 2, 3, 4 and 5. Pass out of this end, 1, 2, 3, 4. So 2 and 3 is smaller than 4 and 1, 2, 3, 4. 3, 4, 2, 4. Prefer this lower number or numbering. So this is now called pent. This number 3 is smaller one, pent 2-ene or 2-pentene. Okay. What if the double bond comes here? What happens? Will the name change? Double bond comes here. 1, 2, 3, 4, 5. I'll put the double bond here between carbon number 3 and 4. That is here. Will the name change on that thing? In this one, if I'm numbering this one now, I will number from this end again because this is the end that is closer to the double bond. That is, this is 1, 2, 3, 4. Why is it give me 1, 2, 3? This end is close proximity. Smaller numbering is preferable in impact nomenclature. So this compound is pent 2-ene. Take the smaller number. So that means this compound have represented for this compound here is certain as the one we drew above. So you see the same thing. So having done that, so let's go to, we can see generate more enzyme, but we'll be coming to that topic later on. Let's go to the condensed formula of pentene. So pent 1-ene, 1 carbon with 2 hydrogen, CH2, double bond, 1 carbon with 1 hydrogen, CH, 1 carbon with 2 hydrogen, methylene group. It appears 2 times, CH2, CH2, CH2. I can bracket and put 2 here because it occurred twice, and then CH3. This is the condensed formula of this one. For this one, pent 2-ene, CH3 here, CH, double bond, CH, CH2, and then CH3. This pent 2-ene. Then going to the skeletal structure of these. 1, 2, 3. Let's see where we are right. Number 1, number 2, 3, 4, and 5 position. Then we put the double bond. We insert double bond. Double bond occur between carbon number 1 and number 2. Go to the skeleton. Now put the double bond here. That is it. Then coming to this one. Skeletal structure. Move to this side. 1, 2, 3. You see 1, 2, 3, 4, 5. So where do I have the double bond? Double bond occurs between carbon number 2 and 3. We go to the structure and insert the bond. So you can see the differences, the two isomers, the same molecular formula but different structural formula and also different skeletal formula. So you can watch what we have done on the board. So always subscribe to the channel. If you are seeing the channel for the first time, tap on the subscription button. If you already subscribed to the channel, we appreciate you. Share our videos to friends, to classmates. Let them join us as we grow in organic chemistry. Moving back to alkynes. Alkynes. And that class of hydrocarbons, by definition, alkynes are also unsaturated hydrocarbons that contain a triple covalent bond between two adjacent carbon atoms and correspond to the general molecular formula of CN H2M minus 2 with N starting from 2, just like the Alkenes. They follow unsaturated hydrocarbons. So that's alkyne, the definition of alkynes. Alkynes, we are formerly called acetylenes. Acetylenes is the general name for alkynes. Even though the first member of the alkyne called ethyne is also known as acetylene, but the alkynes generally are also referred as acetylenes. So we have alkynes, then the triple bond in alkynes. Triple bond is the functional group of alkynes. So all alkynes contain triple covalent bond. Okay? So having done that, we'll now look at the general structure of alkynes. To draw alkyne, a simple alkyne, are placed two carbon atoms. Then between two carbon atoms are placed a triple covalent bond. The presence of a triple covalent bond indicates 4 missing hydrogen, both up and below the plane. I have to remove 4 hydrogen atoms. Then 4 atoms. Then this side are now placed hydrogen. So unlike alkenes, in alkenes you remove 2 hydrogen atoms. When in alkynes you remove 4 hydrogen atoms, 2 above and 2 below. So this is an alkyne. Why do we have to remove 4 hydrogen atoms? So why do we have to remove 4 hydrogen atoms? Because carbon is tetravalent, have 4 electrons around carbon, tetravalent also for this one. You bring 1 hydrogen here from a bond. How do you get from another bond? Another bond, another bond. So, sorry, that's alkyne. Alkyne is C2H2. So that means 2 carbon. Let's start afresh. There is ethyne. 2 carbon atoms close to each other. 4 hydrogen around each carbon. 4 atoms around each carbon that make it tetravalent. Then 2 hydrogen, 1 comes there to bond. 1 forms the bond. They are used 2 hydrogen already. So no more hydrogen. So these 2 electrons will come together to catenate. These will come together and these will come together. At the end of the day, we now have a sigma bond here, a single bond here, and that single bond there. Then these 2 come together, these 2 come together, and these 2 also come together, giving you a pi bond. So having done that, you now see that carbon is surrounded by 8 electrons, 2, 4, 6, 8, the hottest state certified. This carbon, 2, 4, 6, 8 electrons certified. While the hydrogen atom has 2 electrons, that is duplex state. So you see why you have to place, when you have a triple bond, you have to remove 4 atoms up and below the plane. So having done that, we have really understood the alkynes. Now let's go to the derivation of the members of the alkyne family. We say that the general molecular formula of alkynes is CnH2n minus 2, n starting from 2. For the first member of the alkyne family, what would I do? I'll replace n with 2, C2H2 times 2 minus 2. So that gives us C2H2, that is 4 minus 2. Second member, I will have C3H2 times 3 minus 2, replacing n with 3, I have C3H4. Third member, I have C4H2 times 4 minus 2, that gives us C4H6. So I can generate the members if I want, all the members of the alkyne without waste of time. How do you generate the members of the alkyne family? All you have to do is know the first member only, and then generate another one by linking them to CH2 group. That is, since the homologous series has C3, that is 1 plus 2, then 2 plus 2, that is H4. 1 plus 3, that is 4, 2 plus 4, that gives us 6. 1 plus that gives us 4, gives us 5, H8. C, add 1 again, 6, add 2 again, 10. Add 1 again, 7, add 2 again, 12, and so on. So the nomenclature, this is 2. The alkane that has 2 is ethane. This now is called ethyne. Alkynes end with YNE, the suffix. This is the alkane that has 3 is called propane. The one is now called propine, end with YNE, not propene again, not propane. The alkane that has 4 is called butane. This is called butyne. The alkane that has 5 is called pentane. This is called pentine. Pentine, sorry. Hexyne. And then heptine, octine, and so on. It's a similar nomenclature. You can name the alkynes from number 1 to 100 and so on. So that's how you name alkynes. And then let's look at the structural difference between alkynes and alkenes as we described before. Let's use the second member. The second member of the alkane. As the alkane, the member of alkane is called ethane. You see it? Then for alkene, the bond is here. Second member of that alkene. Because the bond will have to remove 2 hydrogen atoms. Remove the 2 hydrogen atoms here. It's called a ethene. Then for alkyne, triple bond indicate that you have to remove 4 hydrogen atoms up and down. It's called ethyne. Look at the structural difference. Apart from the bonds we are seeing here, triple bond, double, and single bond, you see that an alkane has 2 hydrogen atoms more than a corresponding alkene. An alkane has 2 hydrogen atoms, like ethane is C2H6, more than this C2H4. And also an alkane has 4 hydrogen more than a corresponding alkyne. 2 more than alkene, 2 more than this. That is the minus 2, you have this hydrogen. Then minus 2 hydrogen, you have that. Okay. So, having done that, let's look at this small question that says, determine and name the 23rd member of the alkyne family. 23rd member of the alkyne family. Name it and okay, determine the formula, the molecular formula, and name the 23rd member of the alkyne family. It is a very small question. To do this, I don't have to start listing the whole alkynes. All I have to do is to ask myself what the general formula of alkynes. The general formula is CnH2n minus 2. Then for the 23rd member, what will be the value of n? For the 23rd member, n would be equal to 24, if you agree with that. Why is n 24? Why not 23? If it's alkene, n would have been 23. If it's alkene, n will be 24. Alkyne, n will be 24. Because we can say that the alkenes and alkynes obey the innate rule of the position will be m plus 1 for any member. So if the first member will be 1 plus 1, 2. Second member, I'll put 2 here, n now becomes 3. The third member, I'll put 3 here, n becomes 4. Because for the alkyne family, n starts from 2. So if the first member is 2, the second member will have n as 3. They add an extra 1. Third member will have n as 4. That is the third member. So that means the third member will have n as 24, not 23. So we'll now replace n with 24. We'll have C 24, H 2 times 24 minus 2. And that gives us C 24, 48 minus 2 gives us 46. This is the formula of the total member. Then what is the name of this member? If this is alkene, we will call it tetracosane. Being alkyne, we will call it tetra, call it 24. Cosine. Tetracosine. That's the 24 member of the alkyne family. Here we're going to look at the alkynes, the molecular formula, the molecular structure or structural formula of alkynes, condensed formula, and how to write the skeletal or line formulas. So we'll start with the first member of the alkyne family, known as ethyne. Formula is C2H2. So going to the molecular structure of ethyne, as we earlier described in this video, to draw the molecular structure, put the carbon on the straight line, and only two carbons in ethyne. And since alkynes have triple bond, I'll put triple bond between the adjacent carbon atoms, the only 2 of them, and they have to extract 4 hydrogen, 2 below and 2 above removed. So, and the hydrogen this side, and the rest is the ethyne. Condensed formula for ethyne. The first carbon is having 1 hydrogen, I have HC. Second carbon having also 1 hydrogen, but you show the functional group at the middle, and then H. This is ethyne or is condensed formula. Then going to the skeletal form of ethyne, we have triple bond joining the 2 carbon atoms. So that is line formula for ethyne. So number 2 example of alkyne is propyne. Propyne, which is C3H4. So let's draw the molecular structure. Here we're having 3 carbon atoms, 1, 2, 3. And that is a triple bond somewhere, which should be between any of the 2 carbon atoms. Let me put it here. Okay. And this place has a triple bond. We make sure that you eliminate 4 hydrogen up and below the plane. Then you can put hydrogen here, here, there, and there. This is propyne, C3H4. Then the condensed formula. The first carbon has 1 hydrogen, triple bond here, 1 carbon again, and then the last one has 3 hydrogen. So that is propyne. Then to draw the skeletal formula, we have 1, that is 1, 2, 3. Then where do we have the triple bond? Triple bond lies on between carbon number 1 and 2. So I can put an extra line here, and also another extra line underneath. So that is our propyne. Number 3, our butane, which is C4. This is the third member, H6. So drawing the structure of butane, we have 1, 2, 3, 4. 4 carbon atoms. So I can choose anywhere to put my triple bond. Let me put it here. And that means I have to put the hydrogen here, there, 4 hydrogen. So put 1 here, put 1 there, 1 here, here and there. So this is removed. So having done that, we now have SC. There is one carbon, the first carbon has one hydrogen. Second carbon has no hydrogen. Triple bond is between them. No hydrogen. Third carbon has two hydrogen. And then CH3. So let's go back to this compound again. Let them name it accurately. We have to name it. The S string carbon are this one and this one there. Numbering must be a position whereby we have a close number or a smaller value to the triple bond with the functional group, triple bond. So here is 1, 2. This gives us 1, 2, 3, 4. So this is preferable, that gives a smaller value. So how this is 1, 2. So this is 1, 2, 3, 4. This is now called butane, but 1I or 1-butane, the name of the compound. So that is it. Now we go back to this. To draw the skeletal formula, we have 4 carbon, 1, 2, and so 1, 2, 3, and 4. That's right. So the triple bond lies between carbon 1 and 2 in this structure, 1 and 2. So I can put it here, 1 and 2. So this is the skeletal formula for both 1I. Then the question is this: can I generate an isomer here? There is another compound with the same formula but different structure. Yes. Let's see how it goes. 1, 2, 3, 4. Having done that, triple bond can be shifted to this point, so the name will change. Then, having done that, we'll now insert our hydrogen atoms here. There will be no hydrogen atom on this points because of the triple bond. 4 atoms will be removed. So that is it. If you count, you see have your 4 hydrogen and 4 carbon and 6 hydrogen atoms. So having done that, let's write our condensed formula. This is CH3 for the first carbon, C, triple bond, C again, and then this one CH3. So having done that, we can draw the structure, skeletal formula. So we'll see draw something like the previous one. 1, 2, 3, 4. Then we have to put the triple bond. Triple bond lies between 1, 2, 3, carbon number 2 and 3. That is here. We put 1 here. We put 1 here. That is it. So you can look at the two. The two of them look alike, but they are different. Look at each other, the triple bond. They are different from each other. They are isomers to each other. Compound that have the same molecular formula or different structural formula. Let's go back to propine. Some may ask, why didn't I call it prop 1I? Because this is on number 1, this is number 2. So it would have been called prop 1I. No, you can't call it prop 1I, it's just called propine, because if you call it prop 1I, is there anything like prop 2I? If I change the position now, remove the position, remove it, and put the triple bond on this side, with the name change, let's see. The structure will look whether it's different, the same thing or a different thing. So this is the same compound. This is why I have the triple bond. The hydrogen atoms 4 have been removed. The position have been changed from here to there. So if you look at this compound, if you want to number, you see number from this close end to the triple bond. That is number 1 here. So this one is also the same prop 1I. The previous one was also called prop 1I. So because the compound doesn't have anything like isomer, they're not like prop 2I, so the compound the name remains propine. So you cannot call it prop 1I, call it prop 2I, because no matter where the position of the triple bond is, it is at the terminal position, it's at number 1 position. So having done that, we have come to the end of this tutorial for today's lesson, hydrocarbons, alkynes. In our next video, in organic chemistry, we're going to be looking at how the definition of organic compound based on the homologous series. So how to identify organic compounds based on these homologous series. We're going to look at the homologous series in chemistry, organic chemistry, the functional groups present, and because if you're able to know the homologous series of organic compound, you can be able to name it. It's a key to naming organic compounds. So we're going to look at the homologous series in organic chemistry. Then we'll still look after that, we'll now go into full nomenclature of aliphatic compounds. We go into full nomenclature of aliphatic compounds after that. So stay connected, invite your friends. Thank you, subscribers, If you're not subscribed, continue to subscribe to the video so you'll be getting our video from time to time. Thank you and have a nice day.